This video will demonstrate the StatCrunch randomization applet for the difference in two means using new StatCrunch. The data is from problem 53 in chapter 9 in the text as shown here. Is the amount spent on clothes per week for a random sample of 14 women and 19 men. To create the applet, we'll go to StatCrunch, Applets, Resampling, Randomization Test for two means. And this sets up the applet so we can do the input. So sample 1 in, we want to select the amount spent on clothes per week for females, and we'll label that women. Sample 2 in, we'll select amount spent per week for men, and we'll label that men. And then we'll click compute to create the applet. So this shows the applet. On the right side, if you click on data, it shows the original data. So the mean for women, 148.571. Mean for men, 108.947, for a difference of 39.624 if I subtract the mean for men from the mean for women. On the right side of the applet, it sets up two regions, negative 39.624 or below, positive 39.624 and above. Those are important because when we do additional resamples, if the difference in the sample means between men or women falls into one of those regions, it will be more extreme than what we got in the original data. And we want to keep track of the proportion of samples in which the difference is more extreme than what we got in the original data. So to start, we'll click on one time, and when you do that, you can see StatCrunch shuffle the data. The idea here is if the mean for men and the mean for women are the same, then any data point could come from either men or women. So this shows one sample. You can see here that StatCrunch starts to plot a histogram of the data. On the left side, if I click on one, I can see the data for that one sample. Okay, so we'll continue by clicking on 5 times, and when you click on 5 times, again you can see StatCrunch start to build the histogram. So now we have the data for a total of 6 resamples. Okay, we want to do this a number of times, so we're going to click on 1,000 times 3 times, and as we do that, you can see the histogram start to build. So that's 1 time, 2 times, 3 times. So now we have a total of 3,006 resamples. I can look at any particular sample by clicking on that number on the left. So let's look at one that's in red. So in this one, the mean for women was 150.714, for men 107.368, so a difference of 43.346, which is more extreme than the difference we got in our original data. So that would fall in this category of 39.624 or above. Okay, now what's important here is the red area in the histogram and the numbers at the top above the histogram. So this set of our 3,006 resamples, 220 were the difference was below negative 39.624, and 239 the difference was above positive 39.624, for a total of 459, or approximately 15.3% of the resamples. And the area plotted in red here shows that 15.3%. And that area is important when we get into hypothesis testing a little later. This area in red will really represent what we call the p-value in a hypothesis test. The p-value is the probability of getting a difference more extreme than what we got in the original data if the null hypothesis of no difference in the samples is of no difference in the means between men and women is true.